This video covers the review for section 8.5. Number 11, graph the linear function f of x equals negative 3/2 x minus 4 and plot at least 5 points and use a straight edge. And then find the zero of f of x. So the linear function means that we have a slope, which is negative 3/2, and a y-intercept of 0, negative 4. We start at 0, negative 4, and then we rise negative 3 and run 2. Or rise 3 and run negative 2. And connecting our dots with a straight edge, there's the graph of our function. Now the x-intercept is the zero of our function, but this is kind of hard to see what it is. So the zero is found by setting y equal to 0, or f of x. And so we solve 0 equals negative 3/2 x minus 4 by adding 4 to both sides and multiplying both sides by the reciprocal, negative 2 over 3. That gives us x by itself, and we get negative 8/3. So we say the zero is negative 8/3. It's not stated as an x-intercept, it's just stated as a number. And negative 8/3 is negative 2 2/3. And that looks like the right value there, negative 2.67. Number 12, find the zero of the linear function. If we don't have a graph, then we have to set f of x equal to 0. 0 equals negative 2/3 x plus 8. Subtracting 8 from both sides. We have negative 2/3 x equals negative 8 over 1. We multiply both sides by the reciprocal. X is equal to 2 goes in 8 4 times. Negative 4 times negative 3 is 12. So we say 12 is the zero of f of x. Number 13. Suppose that a plane is flying from Chicago to New Orleans. The plane leaves the gate and taxis for 5 minutes. The plane takes off and gets up to 10,000 feet after 5 minutes. The plane continues to ascend at a constant rate until it reaches its cruising altitude of 35,000 feet after another 25 minutes. For the next 80 minutes, the plane maintains that constant height of 35,000 feet and then starts to descend at a constant rate until it lands after 20 minutes. It requires 5 minutes of taxi to the gate. We want to draw a graph of the height of the plane as a function of time. So plane is flying from Chicago to New Orleans. The plane leaves the gate and taxis for 5 minutes. So for 5 minutes, the plane is on the ground. The plane takes off and gets up to 10,000 feet after 5 minutes. So 10 minutes after we started this scenario, we get up to 10,000 feet. The plane continues to ascend at a constant rate until it reaches its cruising altitude of 35,000 feet after another 25 minutes. So that's 35 minutes, and we're now up to cruising altitude. For 80 minutes, after 35 minutes, at 115 minutes, the plane maintains a constant height of 35,000 feet. At that point, the plane then descends at a constant rate until it lands after 20 minutes. So 20 plus 15 is 135. The plane then descends at a constant rate until it lands after 20 minutes. It requires 5 minutes to taxi the gate. And that would be the graph of the height versus the time of the plane after takeoff. 14. In 2002, Major League Baseball signed a labor agreement with the players. In this agreement, any team whose payroll exceeds $178 million in 2012 will have to pay a luxury tax of 40% for second offenses. The linear function T of P equals 0.4 times P minus 178 describes the luxury tax T of a team whose payroll was P in millions. What are the independent and dependent variables? In a function, f of x, the x is always the input, that's always the independent. The output, whatever it is the dependent variable. The dependent variable is always the output. The output depends on what you put in. So the independent variable is P, which is the payroll. The dependent variable is T, and it's the luxury tax. The implied domain of this function, it wouldn't really make a difference. We wouldn't really want to say that P is 0 because we don't pay any luxury tax there. We only pay luxury tax if the payroll exceeds 178 million. So we would start getting something interesting if P is greater than 178. And so letter C, what was the luxury tax for a team whose payroll was 190 million? If the payroll is 190 million, they pay 40% over the 178. So we take T of 190, which is 0.4 times 190 minus 178. So that's going to be 40% of 12, which is 4.8 million in luxury tax. To graph this linear function, notice how it starts at 178. We would pay no luxury tax if we stay at the 178. But what we saw is that if we have a payroll of 190, the luxury tax is 4.8. Let's get one more point on here. How about say 208? 0.4 times 208 minus 178. And that's going to be 12 million. If I can get a line to go through all three of these, then I know it's great. Pretty close. And then the payroll of a team that paid a luxury tax of 12.8. So this time 12.8 is the luxury tax, and that was 0.4 times P minus 178. Solving for P, we'll take 12.8 and divide by 0.4. And that's 128 divided by 4, which is 32. So P is equal to 32 plus 178. So payroll of 210 will mean a luxury tax of 12.8. 210, 12.8 right there. So we have a payroll of $210 million. Number 15, the weekly rental cost R of a Class C 20-foot recreational vehicle is $129 plus the 32 cents per mile, up to a maximum of 500 miles. Find a linear function that expresses the cost R as a function of the miles driven M. So R of M will equal, the slope is here because it's 32 cents per mile, and the fixed cost is $129. The cost will depend on the number of miles driven. So the independent variable, always the variable inside, is the miles driven. The dependent variable is the cost. Or let's call it the rental cost. The domain of this linear function, the miles, in this case, the miles will be greater than or equal to 0. One might argue they should be greater than 0 because you might as well drive the vehicle if you have it. But I don't think that makes a difference. And they're saying that we have a maximum of 500 miles. So that's the implied domain of this linear function. And now if we rent this and drive 360 miles on it, then R of 360 will be 0.32 times 360 plus 129. So the mileage cost on this is 360 times 32. It's 115.20. $115.20 plus 129 is 244.20. That would be the rental cost. If we have a rental cost of $275.56, then that means the $275.56 equals 0.32 M plus 129. So we solve this by subtracting 129 from both sides. And that gives us 56. 15 minus 9 is 6. 6 minus 2 is 4. 146.56 equals 0.32 m. And if we divide 146.56 by 0.32, that's 32 into 14656, which gives us 4. 5 times 2 is 10, 15, 16, and 32 into 56 goes 8. And so that says that we'd have 458 miles. And now we're asked to graph this. We know that R of M is 0.32 m plus 129. That means if no miles are driven, we're paying 129 miles to drive this thing. Using these values we just found, if 360 miles are driven, miles were driven, then the rental cost $244.20. And if 458 miles were driven, it cost $275.56. And there's 3 points on this. And so we'll connect those as best as we can. And so then lastly, over what range of miles can you drive if you have a budget of $273? So we would want the rental budget to be smaller than or equal to $273. We can see by this graph that it's somewhere around the 458 mile mark. So we solve 0.32 m plus 129 is less than or equal to 273. 273 minus 129 is 44. 144. 0.32 m. So m is less than or equal to 144 divided by 0.32. Which gives you 450. So the miles must stay underneath 450 or equal, and we will stay within our budget of $273. And this concludes the video for section 8.5 review.